Welcome to EMScan Lab. Today what we'll be doing is showing you how you can effectively use the high resolution capability of the ERX Plus. Because there's a lot of scan capability, you can generate a lot of data and you can quickly run into very large scans. So this video is meant to show you how you can effectively balance the trade-off between resolution, sensitivity, scan area, and still keep the times reasonable. So what we'll be testing today is a wireless access point. So this is just the board pulled out from inside the component. This is just an off-the-shelf wireless access point. We'll be scanning on the ERX Plus. And of course, ERX Plus is a fully integrated system, no external components required. We just have the Ethernet connection to our computer where we're running the EMXpert software. So we've already done a lot of scanning here. And what we'll do is go through the process as you might when you're analyzing your own board. So the first thing we did is select the entire area of this board. So this is, if we look at the settings, up to 430 probes, and you can see that we're covering from 50 megahertz up to 500 megahertz. Now the system can run up to 8 gigahertz, but most of the critical frequencies that we'll be analyzing are below 500. We set the resolution bandwidth to 122 kilohertz, and you can see we have set up as level 1 with no interleave. If we go over to the signal conditioning, we've turned the internal preamp onto low gain setting, and we have the noise reduction set to level 1. So if we run this scan, it takes about a minute to complete because we're looking at so many probes and over such a large frequency range. After a minute, you can see what we've generated is quite a lot of noise coming from this board. We identify lots of peak signals, and you can see that there is some hot spots in the center of the board. So this certainly gives us a very good starting point to start analyzing the board. And at only a minute of wait time, it's a reasonable scan to get started with. What we'll do next is move on to more sensitivity. So in this case, if we go to the settings, you can see that we've moved from 122 kilohertz down to 7 kilohertz. So that'll give us a lot more sensitivity in terms of the scan, but what it'll do is take more time to run. So as a trade-off to that lower sensitivity, I've reduced the scan area slightly. In that previous scan, we could see that most of the hot spots were around the bottom edge of the board. So here I've just focused on a little bit smaller area, and if we go to the probe settings, in fact, we'll have to open up the scan data description. You can see that I've cut out the top area of the board. So this will shave off maybe 30% of the scan time. Now certainly when we ran higher sensitivity, we picked up some more signals. We have this broadband noise sitting at the bottom here in these frequencies. And we still pick up the main hotspots. Now the resolution here is still level 1. So now if we want to start changing things again, what I'm going to do is try to go to higher resolutions. As soon as we do that, the amount of data that we generate in the scan time is going to start to increase again. So now I want to balance this. I want to focus in on particular areas of the board and analyze those independently. There's no reason for me to scan the entire board at all frequencies all the time. So you can see again what I've done is cut down on the scan area. Now I'm only looking at a smaller area of the board just to the left. So when I do this one, this is again a 1-minute scan. So it's very fast because I've cut down on the scan area. Now I'm prepped. I have my particular area, maybe some frequencies I want to identify, and now I'm going to start to go to higher resolution. So my next scan has now been set to what we call level 3. So this is cutting down the spatial resolution by a factor of 8 times, and it'll generate 64 times the amount of data. And it would take 64 times as long. What we've done is, it's actually going to take about 30 minutes to complete this scan, so actually really only about 30 times as long. But now we start to get that very high resolution scan. So now we can identify different frequencies. We can start to use the spectral spatial capability to pull out different features of this board, different components, different spectral emissions. And we have other videos on the EMScan channel showing you how to do this effectively. Now, as I progress through, I might want to look at even higher resolutions. So to do that, what I'm going to do is keep the same area, because this is giving me some of those key features that I'm interested in, but I'm going to cut back on the spectral range. So you can see by focusing in now from 130 to 190 megahertz, I've really cut down on the span. So this will allow me to do the scans much faster, and you can see we've cut this down from 30 minutes down to 3 minutes. So now this will allow me to go much higher resolution without having extremely long scans. So the final scan that we're going to look at is again cut down on the spatial area, cut down on the span so that we have a reasonable base scan time, but now I can easily go up to level 5, which is half millimeter resolution. And you can see in this case we've actually imported the overlay, so a picture of this board, and you can see with half millimeter resolution we get extremely fine detail with this scan. We get still a lot of frequency signals here that we can pull apart using the spectral spatial, and this scan took 45 minutes. So now that I've identified the particular area that I want to focus in, the most important frequencies that I felt were needed to be analyzed, I can start to commit to these higher resolution scans and still keep the scan time reasonable. So this is a way of effectively using the high resolution capability without getting into extremely long scans on ERX+. If you have any questions or comments, you can post those below. And of course, join us again at EMScan Lab for more videos. Thank you.